Welcome back. So today we're going to look at the car controller. So if we go up, we press triangle, we get into the car, and then it's X to drive forward, and we can turn, and the wheels turn at the front wheel drive, and then if we hold B, we reverse. We sort of brake before we reverse. So if we drive forward, and then we kind of brake first, and then we start reversing once our forward velocity is at 0, I suppose. For the camera, for the car controller, it's actually fixed. So if I move the right stick at all, nothing moves. So it just follows the vehicle. It rotates to the forward direction of the vehicle. A little bit of a delay in it too, so it's not snapping behind it. We can see when we turn the car, for a brief moment before the camera catches up, we can see the side of the car and the wheels turning. Okay, so now let's jump to Unity. Okay, so first thing we're going to do is set up our car. So if we go to the polygon starter and we go to prefabs, and here we'll find a car. Let's just drag and drop that into our scene. And let's just unpack the prefab completely. Rename this to car. And maybe we'll just drag it out from our player till we get a better look at it. Okay, so now let's take a look inside it. We have the glass and other stuff and the wheels. So first thing we're going to do is we're going to organize these wheels. So let's just create an empty prefab. Let's call it wheel models, and then let's just select the 4 of these and drag and drop them into this new parent. We're going to create another empty under this, and I call this wheel colliders. And now let's create an empty under this, and we'll call this wheel FL for front left, and then collider. And then we'll do the same for under this wheel, create an empty wheel FR front right collider. And we'll do the same for the other 2. Wheel RL rear left collider, and lastly wheel rear right collider. Now what we're going to do is select all these. So select the first one and then hold control and select all these colliders, not this one, all these colliders, and drag them under this wheel colliders parent. So now these transforms are the same as the models transforms. And let's select all of them. Let's go add component, and we're going to go wheel collider. Okay, so actually to get the wheel colliders to appear, we need to first attach a rigid body to our car. Now if we look at the wheel colliders, select them all. Let's look from the side. We can see that they're a little below ground. Let's just go to perspective mode to get a better look. And yeah, we can see that they're not quite center of the wheel. So what we want to do here is we have this suspension distance, and as noted in the Unity documentation, we need to elevate the y-axis by half of this suspension distance. So it's 0.3 here. We can simply go to our y and say plus 0.15, which of course is half. And now you can see that they are centered. Now let's bring the radius in a little bit so it's more in line with the wheel. Something like that. Let's go 0.35, but too big, 0.33. Yeah, it looks fine. It looks to be a bit more in line with the size of the wheel. And we already have our rigid body on our car. Let's just drag it up so it's a bit higher in the hierarchy. Okay, so that'll do for now for setup. Let's write some scripts. So let's go to our scripts folder and let's create a new folder, and we'll call it vehicle. And we'll go inside that and we'll create a new C# script, and we call it vehicle controller. Double click to open. So a lot of this is going to be adapted from the Unity documentation. They have an example car controller script. This is going to be a lot better, but we're going to use a lot of their setup to get the physics right. So we can delete this stuff. And first, we're going to need a rigid body. Let's just call it rigid body. Same way for a player. We're going to be calling this in our game manager. So let's go public void vehicle init. And we're going to say rigid body equals get component rigid body. So now let's look at the rest of the variables we're going to need. Let's go serialize field. So we're going to need a float, and this is going to be called motor torque. So this is the driving force of the motor. And let's just equal this to, let's put it at 1500. Our next is going to be our serialized field. It's going to be our float. And then this one is going to be the brake torque. And we'll equal this to something larger than the motor torque. Let's go 6,000 for now. Let's create another serialized field. Float. This will be our max forward speed. And let's just set that as 20 for now. And then float. And this is our next one is our max reverse speed. Because reversing is not as quick as going forward, so we want 2 different speeds here. So let's set that as half now, we'll set it as 10. Now the next thing we're going to set up is our steering range. So float steering range. So this is going to be how much we can move our front 2 wheels. So let's default this to 30. So it's 30 degrees. And now we'll do serialized field. Let's remove these extra square brackets. And we'll say float steering range at max speed, because steering will be lessened at max speed. Let's set it to 10 for now. Now to properly stabilize the car, we're going to set up some variables for the center of gravity. So let's say serialized field, and then this will be a float again, and this is going to be called center of gravity offset. And we'll just default this is -1. And our last variable for now, we'll come back and add some more later, but for now we're going to add some stopping speed. So when you're not reversing or going forward, that slow braking of the car once it runs out of momentum, that's what this is going to control. So float stopping speed, and let's just default this to 3. So now in our init, let's set up the center of mass. So rigid body actually already has a center of mass by default. It configures itself based on the transform, but we're going to add some stuff to this. So rigid body dot center of mass plus equals, and now it's going to be vector3 dot up, and then we can multiply that by our center of gravity offset. Let's create an update method as well. So public void vehicle update. And now let's create a new method, void handle drive, and we'll just call that here. Now of course we're going to need our input container, so let's just get that here, input container. Let's call it input container, and yeah, this is going to be fed into this method, so let's just add this here. Now let's start working on our method. I'm going to create an integer, and I want to call this move direction. So maybe it's strange if an integer they represent a direction. Usually you would have a transform, but if you bear with me, if input container dot b input dot held. So if you translate that to a PlayStation controller, it's a circle button, and in the game that's reverse. So if that's the case, then move direction will equal -1. So we're going in reverse. Else, if input container dot a input dot held, which is X on the PlayStation, and if you're doing that, you're driving forward, so move direction will be 1. And then if it's neither of those, so you're not pressing any of those buttons, move direction will be 0. Now let's first calculate the current forward speed. So float forward speed equals vector3 dot, so this is the dot product of our transform dot forward and our rigid body dot velocity. Now let's see what the max speed we're going to go is. So float max speed, and then if move direction is greater than 0, so we're going forward, then it'll be our max forward speed, and if not, it'll be our max reverse speed. And when this is 0, it won't really matter because we won't be applying the speed anyway, so just checking if it's greater than 0 is good enough. Now, float speed factor is going to equal math f dot inverse lerp between 0 and our max speed, and then our lerp amount is going to be our forward speed. For our current motor torque, based on these variables we've already captured, let's say float current motor torque will equal math f dot lerp between the motor torque that we have in our variables, 0. And now this lerp amount will be our speed factor. And lastly, for variables in this method, we're going to say float current steer range. It's going to be math f dot lerp, and this is going to be between our steer range and our steering range at max speed, and our speed factor again is the lerp amount. So I just see here we have a bit of an issue. Let's just rename this to range. Now the next thing we need to do is apply these values to the wheels. So if they're going to be spinning forward or spinning reverse or not moving at all. But first we need to create a wheel object. So it's actually going to be our own object. So let's go back to our scripts. Let's create a new C# script. Let's call it wheel. Double click to open. We can delete all this. And this is going to be a very simple script. So we're going to get the wheel collider. So public wheel collider. And we'll just call it wheel collider. And let's just hide this in the inspector as well. So hide inspector, that's fine. And now in our, let's go public wheel init. And of course here, wheel collider will equal get component wheel collider. This will be public void. We also want to get the wheel model so we can rotate it to the same rotation as the wheel collider so we can actually see it animate. So let's just say serialized field transform, and let's say wheel model transform. Now if we create an update method, public void wheel update, this is a small hinge. This is where we'll set the position and rotation from our wheel collider to our wheel model. So let's just create a few more variables up here. So vector3, let's just call position, and then quaternion, call that rotation, and now it'll be wheel collider dot get world pose, and then we'll say out position and out rotation. Now then we just apply that to our wheel model transform. So wheel model transform dot position equals position, and wheel model transform rotation equals rotation. And the last thing we're going to do here now is add parameters here, add some booleans for if this wheel is motorized. So of course, if it's a front wheel drive car, only the front two wheels will be motorized. If it's a back wheel drive, the opposite. So public bool is, remove this extra L, is motorized. And then the other one we want to create, public bool is steerable. And same thing again, not everything's going to be steerable. We want to make this very dynamic so we can actually apply this not just to a car but maybe a lorry. Let's just remove these extra usings as well because we're not using them. And that's it for the script. We go back to our vehicle controller now. Let's go back to the top here. Serialized field. This time we get our wheel. It's going to be an array and we'll just call it wheels. Bring this back up to the same line. And then let's make sure we initialize our wheels. So for each wheel in wheels, we'll just say wheel dot wheel init. And now let's go back to our drive method again. And of course, in here is what we'll call our wheel update, which we'll place in a for each loop. So for each wheel in wheels, here we'll say wheel dot wheel update. Now let's put some logic in here for handling each case, rather than going forward, reverse, or no input is given. So for that, we're going to use a switch statement. So switch, and we're going to use that on our move direction. Now, in the case that it's 0, we're going to say wheel dot wheel collider motor torque, and then that'll just be 0. if we're not given any input. And then for our brake torque, we'll say wheel collider dot brake torque equals, and then what we're going to do is lerp between the current brake torque and our desired brake torque. So math f dot lerp. So as I said, wheel collider dot brake torque, and then we wanted to lerp towards our brake torque variable, and then that is going to be by time dot delta time multiplied by our stopping speed. And that'll be it for this case. So let's put brake, and now in the case that move direction is 1, we'll check if the current wheel is motorized. So wheel is motorized. In that case, we'll say the wheel collider dot motor torque equals our current motor torque. And regardless if it's motorized or not, we can just set the brake torque as 0. So wheel collider brake torque equals 0. And then we can just brake. We'll finish this case as well for now. And then in the case that it's -1, we're just going to do the same as this, but this time it'll be minus the motor torque for our brake. And then let's just add a default as well, and let's have it as brake. Okay, so the only thing we're missing now before we can start testing is setting the steer angle of our wheels. We haven't used this variable yet. So this is at the top of the for each loop. We'll say if the wheel is steerable, then wheel collider dot steer angle equals, now this will be our input container, dot left stick dot x. It only goes left and right, not up and down, so we're not concerned about the y. And then we can just multiply that by our current steer range. Okay, I think we're time for testing. Let's double check everything first. Okay, so let's just rename our rigid body to RB, just to get rid of that error. And let's delete these extra usings because we're not using them. Okay, so let's go back now to our game. Let's click on our car and add our vehicle controller. Let's just drag this up, and let's now change the mass of the car as well. So this is actually in kgs. So we'll change this from 1 to, let's put it to 1500 kgs. Now let's actually go to our wheel models and let's remove these colliders, these sphere colliders that are on them, because we don't need these. So let's remove component, and then on our actual wheel collider objects, on our wheel collider parent, we're going to add the wheel script we just made, and now let's assign the correct model to each. So for our front left, drag and drop our front left model in. This is motorized and it is steerable. For front right, drag in our front right, same thing, is motorized, is steerable. And then our rear left, we can just drag and drop this in. I'm not going to make this motorized, it's going to be a front wheel drive car, but you can make a back wheel drive if you want. Our reversed right, drag and drop that in. Okay, so that's fine for now. Now let's go to our game constants, let's go to our game manager. So what we're doing now is going to be temporary. And the next lesson we're going to make this more modular so the player can actually get in and out of the car and it's more dynamic. But for now, we'll just do this quick and dirty method for testing. So let's go serialized field, vehicle controller. It's called vehicle controller. And then if vehicle controller is not equal to null, we'll say vehicle controller dot vehicle init. Let's just create a little boolean here too. Bool is driving, and then we can just say if our vehicle controller is not equal to null, then is driving equals true. Now if you go down our update, if is driving or if not is driving, then we can update our player. But if we are driving, then we don't want to do that. So else vehicle controller dot vehicle update, and this will also take in our input handler dot input container. Okay, so I think we should be able to test now. Let's drag and drop our car in the vehicle controller slot. Let's look at some of our variables. So now we'll have to add these colliders to our wheels. So let's just right click and lock this inspector. Now let's go to our wheel colliders, select all of them, and then drag and drop into this array. And let's just unlock this before we forget it. So I think these variables are fine for now. Let's press play, see what happens. Okay, so obviously the camera still works at looking at the player, but we're actually controlling the car at the moment. So we can see that our wheels are turning correctly with the move of the left stick. And if we hold X, we start moving. And there's some serious drift in there. And I'm not holding X anymore now. Comes to a halt. If we hold B, we start reversing. And again, a lot of drifting. We'll fix that in a second. But first, to get a better feel of this, we need to create the camera we need. So we're not going to be reusing the current camera for the player because it's different. So let's go out of that. Let's go to our scripts. Let's go to our camera scripts and create a new C# script called vehicle camera. And this is going to be very, very simple. So it is. Let's delete all this. Let's first capture our M transform. So transform, M transform. And we're not going to add this to our game manager because it's not really tied to any other logic. So we'll just make a start method and we'll say M transform equals transform. And now we're going to need a follow target. So serialize field transform follow target. And now we're going to update this in fixed updates. Let's create that fixed update method and we'll say M transform dot position equals our follow target dot position. So this will be locked in with that, whereas our player third person camera has a follow speed where it catches up to the player. This will just be locked at it, so we don't need any speed. What we will need though is rotation speed, because we don't want that to be locked to exactly the front direction of the vehicle. We want that little bit of a turn, just like the game. So let's go up here and create another variable, serialize field float rotate speed, and then simply all that is going to be is quaternion. Let's call it target rotation, and then that will equal quaternion dot spherical slurp, and then between it'll be from our current rotation, so M transform dot rotation to our follow target dot rotation, and then that is just going to be lerping in our rotate speed multiplied by time dot fixed delta time. And then we don't want to rotate on the X or Z axis, so let's just say target rotation dot X equal that to 0, and same for our Z, target rotation dot Z equals 0, and then simply M transform dot rotation equals target rotation. And that's it for our script. Let's remove these usings again. That's how simple the vehicle camera is. So now we go back to our game. Let's create an empty called vehicle camera. Let's reset the position. Let's make sure it's in the center of our vehicle at the same position on the X. So the car is at 3, so is the camera. And now under that, let's right click Cinemachine and then just a virtual camera. We can leave it being called virtual camera. We can change the body to do nothing and the aim. Let's reset. Now let's pull this back. Let's see if we can get a good angle here. Move it up. Okay, that's too close to the car. Let's pull it back even further. Let's pull it up. I think that looks quite good. Now on our vehicle camera object, not the actual camera object, but the kind of the holder, we'll add our vehicle camera, and our follow target will be the car, of course, and the rotate speed, let's set this as something quite low, so I think 5, and for now let's just set the priority of this to 20, so once we press play we won't see our player camera, we'll see this one. So let's just try this now, press play. Okay, so if we move, it follows and it also rotates as well. We see the side of our car as it tries to catches up to the forward direction. So this is looking good. We can move forward, we can rotate, or we can reverse. Okay, so one problem is if we're driving forward, and especially when we pick up some speed, well, one problem is drifting. Another problem is if we pick up some speed and then we go to reverse. It actually takes a long time for it to go in reverse because we need to kind of undo the forward velocity first, work backwards until we get to 0 and then back again. So I think what we're going to do is apply some braking when we try to reverse, and we'll do the same too if we're going forward. So if we are reversing and when we try to go forward, we'll apply some braking and then we'll move forward. Let's also just quickly fix this drifting because that's mostly just to do with the wheel collider. So let's unclick play. Let's go to our car and look at our wheel collider. So definitely I think for the back two wheels, if we look at the sideways friction, we can increase the stiffness. Let's say to 2, so make them less slippery. Let's try this again, see how this looks. Let's go, pick up some speed. Yeah, that feels better already. We're not drifting all over the place now. Let's try reversing. Okay, so the front wheels still have that slipperiness on them, so we'll increase that. We'll not put it as high as the back wheels, but we'll definitely increase it somewhat. And another thing I think I want to change is the suspension for the back wheels. So I like having the bounciness in the front two wheels, but for the back wheels I want a little bit more stiffness in the suspension. So let's look at our two back wheels and let's go to suspension spring. Let's change this from 35,000 to, let's make it 55,000. And then let's go back to our front two wheels and let's change this sideways friction stiffness to, let's say 1.5. Let's test this again. And there we go. Let's try reversing now, see how that feels. So again, it takes a long time to reverse because our forward velocity was just so high that it pulls the car forward. So yeah, you can see there we traveled a lot there just from holding down the forward button for a while. But now if we turn around reversing, yeah, there's a little bit of slippiness there, but I think it's fine for the front wheels. Okay, so let's fix this braking issue. So let's go back to our vehicle controller. Let's go back down to our switch statement. I think the code for if the move direction 0 is fine. Now, if it's 1, let's check if our forward speed is less than 0. So that means, we're currently moving backwards. Then what we're going to do here, let's just copy and paste this in. So if the wheel is motorized, our motor torque will be 0 because we want to brake. Put that to 0 and then put our brake torque as brake torque, and then we'll say else. So now this is just back to our normal, so we're not moving backwards anymore. We're somewhat stationary. Now we can just move forward. And that should be it. Let's just copy and paste this now into here. Let's just paste it over this. And then this time it'll be greater than 0. And we need to change this to minus the motor torque again. And I think that should be it. Let's go back to our game. We'll press play. So now if we drive forward, we come to a stop. And now if we reverse, there we go. It comes to a stop. We go forward and we try to reverse. It really puts the brakes on before it starts reversing. And we have a reverse speed too less than our forward speed by design. I think it's good like that. And yeah, this is looking quite good. The rotations are good, the movement's good. So that'll do it for this lesson. One thing we're missing now is collision or damage. So if we drive into our NPC, nothing happens. Same for our crates, nothing happens. So in the next lesson, what we're going to do is add the logic for damage collision. Another thing we're going to do is make this more modular. So at the moment, this only worked for this one car, but as we know in Simpson Hit Run, the world is full of different cars, different vehicles, and we want to be able to reuse our code dynamically for different vehicles. So we'll be making prefabs, and we also need to add the functionality for our player to walk up, press a button, and then enter the vehicle. Make sure you subscribe for that, and as always, thanks for watching.